Well, good evening, grade 11s. A few of you have asked me to post solutions to the practice test, so I'm going to do that. I'm not so sure if the test will be on Monday. Mostly I'm not quite ready, so we'll see, but I'll try to get it soon, so like Monday, Tuesday, Wednesday, that kind of thing. But all right, let's go through this practice test, and I hope you found that that's pretty straightforward, but anyway, I'll take them one at a time. And I'll even narrate the multiple choice because, you know, like I said, you guys are special. Okay, so look. Part A, multiple choice. Okay, wagons being pulled horizontally. What is the horizontal component of the applied force? In newtons. Well, the force is 42 newtons, not the weight of the object, but the force. It's kind of not labeled well there. And the angle is 25 degrees. So let's just see if we can. That angle there is 25 degrees. So there are two components. There's one like this, right? And I'll use rainbow. One like that, okay? Now, which one goes with cos and which one goes with sine? Well, you know components go with cos and sine. The adjacent side always goes with cos because of SOHCAHTOA. The opposite side goes with sine. And so the answer is it's going to be 42 times the cos of 25. That is the horizontal one. So that's the one right there. A northbound truck collides with a parked car. The action force is considered the force of the truck on the car. So the truck is heading north, hits a parked car. Okay, which of the following is true about the action force? So the action force is acting on the car. Okay, that's the thing. So this truck traveling north hits the car. Which of the following is true? Does it accelerate the car northward? Yes, it would. Because, like, you know, if a truck is traveling north and hits you, it's going to push you north. Okay. Does it accelerate the truck south? No. The reaction force does that. The truck does accelerate south because of this collision. But it's the reaction, not the action, that does that. It's the force of the car back on the truck. It acts south. No. It acts south on the truck, but north on the car. It cancels the action force. That's never true. It causes both the car and truck to accelerate. Well, the action force is only acting on the car, but not the truck. Okay? So it looks like the only possible answer is A, and that's the correct one. All right, two blocks are in contact with each other as shown on the frictional surface. The applied force is 85 newtons. What is the acceleration? When we're finding the acceleration, we always combine these forces. And so what we do is we're going to, combine the forces, combine the masses. 6.8 plus 5.2 is 12 kilograms. So I'm just going to use F equals ma. And A equals F over M, that's what I'm going to do, but I'm going to go 85 divided by 12, right? So 85 is the force, so 85 divided by 12 is 7.08, so that's your answer right there. All right, great. Slides across the table. Coefficient of kinetic friction is, what is the magnitude of the force of friction? Well, this is where we use that the force of friction is mu Fn, but because it's a horizontal surface, it's mu mg because Fn and mg are equal on a horizontal surface. So all I have to do is go 0.17 times 1.531 kilograms times 9.8 is 2.55 newtons, and that is D. So there you go. The force of gravity on a 10 kilogram mass is 130 newtons. What was the acceleration of the mass? Well, G is just equal to the force of gravity divided by mass. So it's 130 divided by 10 is 13. All right, the gravitational force between two masses is tripled. Or sorry, between two masses is 36 newtons. The distance is tripled. So the original force is 36. The distance is tripled. What's the new force of gravity? Well, this is a proportionality question. So force of gravity will equal the old force. And triple is 3, but it's divided by, remember that the force of gravity is inversely proportional to the square of distance. So it's going to be 36 divided by 9, which is 4 newtons. 3 forces are acting at the same time on an object. What is the net force on the object? Let's see, 2 east, 6 west, and 3 east. Combine the, here, let me circle them, rainbow for them for you. These 2 are east, that's a total of 5 east and 6 west. So the net would be 1 west, right? So there's your answer. Okay, a cup filled to the brim spills when you're trying to move it while it's initially at rest. What law best explains why? Well, the first one is inertia. Second one is F equals ma, third is action and reaction, and the fourth is universal gravitation. So which one best describes this, okay? And it's initially at rest, and an object at rest tends to stay at rest, so that's what it is right there. Person on a bathroom scale accelerating up. So your free body diagram, oh, that's awful. Your free body diagram looks like gravity, a normal force, and some acceleration like that, right? So what effect does this have? Well, this, let me rainbow that. This normal force changes when you're in an elevator. Now, when you're accelerating up, the normal force increases because it has to be bigger than gravity. But if you're accelerating down, the normal force decreases. So this time you're accelerating up. So therefore, the scale reading, and this is what the scale reads, okay? The scale reading will increase. So the answer is A. All right, so here we just use a formula, and the formula is force of gravity equals G m1 m2 over r squared. Just go ahead, plug in all the numbers, and 6.67 exponent 11 negative times 20,000 times 20,000 divided by 2 squared is 4, so I get this answer. All right. So there you have it. That's your multiple choice. That took us 7 minutes and 20 seconds. So pretty good. You guys are quick. All right. Now, let's do this black hole question. It's such a cool question. These are actual numbers too. Okay, so like a black hole is a remnant of the dead supermassive supermassive star. True story. Okay. One of such objects has a mass of that is about 20 solar masses. This one here. And stars like that, well, black holes, usually it's 30 solar masses, but the thing is that black holes, when stars die, they shed a lot of mass before they become a black hole in the supernova. So anyway, so this one's pretty big, about 20 times bigger than our sun, okay? And it has a radius of just, this is smaller than Earth's radius. Earth's radius is 6.4 times 10 to the 6. So it's bigger than 20 suns, and yet smaller than Earth by quite a large margin here, okay? How much would a 70 kilogram student weigh on the surface of the black hole? They'd never survive it, but anyway, we just do this. Force of gravity equals G m1 m2 over r squared. Plug in the numbers. Okay, so you go 6.01 exponent 31 times, I'll do the 2 masses first, times 70 times 6.67 exponent 11 negative equals divided by 8.89 exponent 5 squared equals. Woo, that is a lot of weight. 3, 6, 9. I get 3.55 times 10 to the 12 newtons. Now, in case you're wondering, that would be the same as weighing 100 billion tons. So how heavy would you feel standing on that black hole? As if you weighed 100 billion tons. So that's more than the weight of like probably Mount Everest. Like you would feel extremely heavy. Of course, you'd be crushed by that kind of weight. But anyway, so there's your answer. All right, number 2. 2 blocks, blah, 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 coefficient of kinetic friction is 0.24. What is the acceleration of the system? All right, that's question A. So now, free body diagram. of both blocks together. That's always how we find the acceleration in a connected system. So I'm just going to circle, we're going to treat them as one object. So if you look at what I drew in the circle, the free body diagram, there's gravity, there's a normal force because they're on a surface, there's the guy pulling, right? And it says here this force is 30 newtons. Okay, now friction will have to counter us. So that is your force of kinetic friction. They're asking us for the acceleration, so there's a free body diagram. So now, from the y components, what we get is 0 net force in the y direction equals Fn minus the force of gravity. This force of gravity is mg. Okay, so therefore Fn equals mg. That happens all the time. Okay. Now in the x direction, we have ma equals, and my two horizontal forces are the applied force, call that one applied, minus the force of friction. Those are my two horizontal forces. So I'm going to write 4.2 and 6.4 make 10.6, so 10.6a equals mu is 0.24. Oh, so pardon me, let me put the applied force first. So it's 30 newtons minus 0.24 times 10.6 times 9.8. Okay, now I'll solve that for a. So I'll just go ahead and do it. It's going to be, I'm sorry, I'm not writing every single step, but like I hope you get that friction will equal mu Fn. You get that, right? And Fn is mg, so it's mu mg. Okay, and that's what I put for friction here. All right, so let's go ahead and do it. 30 minus 0.24 times 10.6 times 9.8 equals 5.0688 divided by 10.6 equals, I got 0.478 meters per second squared. Okay. All right, let's keep going. So what is the tension in the rope joining the two masses? Now to do that, I'm going to use a rainbow color here. We're going to draw just the free body diagram of M1, okay, in that picture, because it's just being pulled by the rope and it's the simplest one to draw. So free body diagram of M1, what does that look like? Well, gravity. It looks just like the last one, by the way. Yeah, there's one difference though. There's a normal force. There's the force of tension pulling it forward. This time we want to know what that is. There's acceleration of 0.478 meters per second squared, which is not unknown this time, so that's the difference. And there's still friction. So if you look at these two diagrams, what's really different is what's not known about them. And M1 is only 4.2 kilograms, so that is also a difference for the mass. All right, why don't we just get straight to the x component. The x component looks like this. Ma is equal to Ft minus the force of friction. So I'm going to get 4.2 times 0.478 as my acceleration equals the force of tension minus 0.24 times 10.6 times 9.8. Oh, not 10.6, pardon me. 4.2, because it's only... All right then. So now that we have all our numbers, there's just one unknown. So I'm going to go, I have the acceleration stored in memory, so times 4.2. Okay, get that. And I'm going to go plus 0.24 times 4.2 times 9.8 equals, and I get 11.9 newtons. So the force of tension, 11.9 newtons. Now I'm doing this really fast. Hopefully I'm not making mistakes, but I'm sure you'll let me know if I did. All right, number 3. What is the net force? You should recognize as soon as you see north, south, east, west, like here, west, south, you should be thinking about components whenever we have a two-dimensional problem like that. Pardon me. So, yeah, let's go ahead and do it. We need, I'm just going to pick two directions to be positive. I'm going to go with east and south. I mean, it really doesn't matter. Okay. All right, so I'm going to break down my vectors one at a time. I'm going to start with this one. I'm going to go clockwise, starting with number 1 there. So vector number 1 is 250 west, so I'm going to write negative 250, 0. Okay. Vector number 2, I'm going to write, this is 45 degrees north of east, so I'm going to write 600 cos 45. That's this component here, right? And then this component here is 600 sine 45. So 600 sine 45, and I pick south as positive. That one's north, so I'm going to make it negative. All right, that's vector number 2. Vector number 3 is due south. That's easy. 500, 0. Okay. All right, so now let's just go ahead and tally everything, right? So I go 250 negative plus 600 times 45 cos minus 500. Oh, I made a mistake. That's 0 and 500, pardon me. Okay, so now that I fix it, let me do that again. 250, I'm glad I caught that. Plus 600 times 45 cos. I get 174.26. This is 174.26 newtons, but I'll just leave it. Okay, and then 600 times 45 sine, negative, plus 500. I get 75.73. Okay. All right, so there's my 2 components. Now all I have to do is put them together. So therefore, my net force will equal the square root of, it's Pythagorean theorem, right? 174.26 squared plus 75.73 squared, like that. So let me do that. That squared plus 74.26 squared equals square root. I get 190 exactly. 190 newtons. And then tan of theta. I'll do it just over here. Small over big. I'm writing out everything just so you can see it. 75.73 divided by 174.26. Okay. So MR divided by 174.26. Inverse tan, I get 23.5 degrees. And that would be south of east. Okay, so there's your net force. I'm just going to circle it. It's 190 newtons, 23.5 degrees south of east. Okay, you need both of those things to get it. All right, moving on. So a car can accelerate from 0 to 100 in just 3.5 seconds. That reminds me of my car. Okay, so just a second. Okay, so what is the force required to achieve this? So what you do is you're going to do one of these. As soon as you see speeds and times and so on, it's a motion equation thing. So you're going to go V1 equals 0, V2 equals 100 equals 27.778 or whatever meters per second. Make sure you convert. Time is 3.5 seconds. Delta D is don't care. And we're looking for A. Okay, we're looking for acceleration. So just go ahead and use equation 1. A equals V2 minus V1 over T. So what's A? Well, it's going to be 100 divided by 3.6 equals divided by 3.5 equals I get 7.94 meters per second squared, right? And F equals MA. So that's going to be 1230 times 7.94. So I'm just going to go times 1230. And I get 9,762 newtons, approximately. Okay. Now, what's the minimum coefficient of static friction? Well, here's the deal. If you draw a free body diagram of the car, see what makes cars travel in the first place is actually an effective force of static friction between the tires and the road. And so this is your net force, okay? Now here's the deal. In the y components, you're going to get Fn equals mg, okay? So that's because the vertical forces cancel. Now in the x direction, let's do it here, your net force is just equal to the force of static friction. That's it. So Ma equals mu mg. We can see that we actually don't need the mass of the car. We're just going to say mu equals A over G, which is 7.94. 7.94 divided by 9.8. And I get 0.81. So that's equal to 0.81. No units because it's a coefficient. So mu, I'm sorry, my mu looks terrible. Mu S. Okay. And there you have it. All right. So number 7. Why are you guys sending me Snapchats right now? That's funny, Keith. The longer he's in the group chat, the scarier the smiley face becomes. Yeah, it's kind of funny how that works, right? All right, so now I'm going to. And another question came up? Is it going to be open book? Well, I guess it kind of is, right? So that means I'll make it extra special for you. Very difficult, of course. I'm just kidding. It's a pandemic, guys. Like you, we'll try to make it easy. All I care about is that you get some learning and knowledge from this moving into grade 12, right? Like, I mean, we want you to get your education. Okay, so, you know, the only reason you get tests in the first place is to basically encourage you to actually study it and know it. Okay, so it's up to you how this works out, but I really hope that you get an education here, do the best we can with what we have. All right, so here. Okay, free body diagram of, what do we have? This is M1, so that's 7 kilograms here, so that's M1. So let's do M1. Okay, so M1, what does it look like? Gravity. Tension. This one's going to win because it's bigger. The bigger guys win in these pulley systems. All right, so that is the acceleration. Okay. Now, there's only vertical forces here, so the net force will equal, we always take the direction of acceleration as positive, so it's going to be Fg minus Fg minus Ft, like that. Ma equals Mg minus Ft. Okay. Now it's 7 kilograms, so 7A equals, and let's just multiply it out. 7 times 9.8 is 68.6 minus Ft, like that. 2 unknowns, so moving along, we'll call that equation 1. All right, now let's repeat for M2. Okay. Free body diagram looks exactly the same with one important difference. There's gravity, and there's tension on that one too, pulling up. That's for this guy, right? But the difference is, if M1's going up, M2 must be going down, and so we're going to make down positive for that guy. Oh, actually, what am I doing? M1 is going down, so M2 is going up, pardon me. So we make up positive for that guy. Yeah, that makes sense. Okay, so the net force this time, Ft minus Fg. See the difference, right? This one was Fg minus Ft, but this one is reversed, this one here, because now we're going with up as positive, and that makes all the difference. So this is a 3 kilogram mass, so 3A equals, let's multiply it out to get the gravity. It's going to be Ft minus, and then 3 times 9.8 is 29.4. All right, so this is equation number 2. Now you've got a system of equations. There's 2 unknowns. I'll use my rainbow color. A is one unknown, and I'll use my blue color. Ft is the other unknown. Okay, so 2 equations, 2 unknowns. You can use whatever method you want, but I like to use elimination. So what I'm going to do is I'm going to write equation number 2 over here. So that's just equation number 2 written again, and I'm going to add the equations together. 10A, those 2 go away when you add them together, because negative Ft and positive Ft will cancel when you add them. And I get 68.6 minus 29.4. So that's 39.2. So therefore A is 3.92 meters per second squared. Okay, so we did one of the questions, we found A, but the question is asking us for A and the force of tension. So now it's just substitution now. 3 times 3.92, I'll just use equation number 2 here, equals Ft minus 29.4, and to make a long story short, I go 3 times that number, so times 3 plus 29.4, 41.16 newtons. Piece of cake. All right. This one, I believe I gave you already as a practice problem when I did components or whatever, showing you how to do the assignment. Okay, but it's okay. We'll do it again. It's our last question, so let's go ahead and do it. I think these are kind of the hardest one. It shows do you understand the component method and do you understand how to draw a Freebody diagram, so it's very important. All right, so what they tell us is in this picture, the person is pushing with 130 newtons, and that angle is 50 degrees, okay? Now, let's go ahead and draw the Freebody diagram over here. This is a system diagram. We're going to draw the Freebody diagram. So, Freebody diagram of the lawnmower. Yes, there's gravity. Yes, there's a normal force. And yes, she's pushing down like this with a force of 130 newtons. And we know because we're you guys are such geniuses at trig and at like geometry that you can see that this angle would also be 50 degrees, right? Just by thinking about that opposite angle over there, okay? All right, there must be friction too because it says it's a constant velocity, so therefore there has to be a frictional force opposing us, otherwise it would accelerate. But here, there is no acceleration because it's constant velocity. That's how we know that, okay? A lot of students will miss that. Now, I'm going to use my rainbow color. This 130 newtons is not on the axis, it's off axis, okay? So off axis vectors, we have to break into components that are on the axis. So in this case, my axis is x and y, right? So you can see that 130 newtons is not on the axis, but the other vectors are on the axis, okay? All right, so let's go ahead and answer the question, what is the frictional force? Well, pretty straightforward. We only have to look at the x component to get that. So let's go ahead and do it. This one's going to go with cos. That one's opposite, so it goes with sine. Okay, we've seen this before. The net force in the x direction is going to be the rainbow vector minus the friction. So it's going to equal the applied force times the cos of 50 minus the force of friction. Now MA will equal 130 cos 50 minus FF. Now since A is 0, that's 0 then, okay? And therefore the force of friction is just equal to 130 times the cos of 50, and what is that number? I get 83.6 newtons. So there you go. All right, determine the normal force. Well, here's the deal. This is the tricky question, but we don't need to draw the diagram again because we already have it. Okay, so we're just going to refer to this diagram up here, and the normal force is on the y-axis. So we're going to go ahead. I'm going to say up is positive. Okay, now, what vectors are up? I'm going to circle them with a rainbow. Or what vectors are on the y-axis? This guy is on the y-axis. Gravity is on the y-axis. And then this guy here, this blue vector, is also on the y-axis. So there are three vectors. 2 of them are down and 1 of them is up. So let's do our up one first, Fn. Then I'm going to subtract. And I'll subtract my force of gravity. But then I also have to subtract my applied force times the sine of 50. Okay, it's the other component, right? It's the blue vector. This is the blue vector in the picture. Okay, so I get MA is equal to Fn minus mg minus 130 sine 50. Now the mass of the lawnmower, here's where we need it, is 15 kilograms. This is 0 because A is 0, so it's equal to Fn minus 15 times 9.8 minus 130 times the sine of 50. Now there's only one unknown, it's the normal force. So now I'm just going to go ahead and find it. And what do I get? Well, I get 130 times 50 sine equals plus 50 times 9.8, just moving to the other side. I get 246.6 newtons. So I get Fn equals 246.6 newtons. And there is your answer. So let me go back through the test and circle the answers. Okay. This is my answer here. I already circled those. I already circled that. And this one I didn't circle. So there you go. There's all your answers. Oh, was I missing one? I'm missing the first one, the black hole question. How can I forget? Where you weigh the same as Mount Everest, right? All right, so anyway, there you see all the solutions, and it took us start to finish 33 minutes, and that's with me explaining everything too. Like, so that actually takes longer. I'd probably do it faster if I wasn't explaining it. But of course, I know that it would take you a little bit longer because you have to think more and remember more, and it comes more naturally to me because I've been doing this like forever. So, guys, that's the test. So I hope you find that's okay. If you have any questions, just ask. We'll see about the test on Monday. I'm trying to figure out the system of how to write the test. I'm having a bit of a hard time, pardon me, with it. So I will let you know, but early in the week for sure we'll have some kind of test, and it will be open book, only because, I mean, you're going to have that, and there's really nothing to prevent that except the honor system. I just want to tell you though that, like, remember the goal of this. Like, what are we doing this for? Like, of course, it's not an ideal situation. We're here in the pandemic and everything, but remember, like, what I care about is that you get your education out of this, which means, like, you know, the only reason why I like giving tests is because some people, if they don't have a test, they don't really care. Like, they don't really, unless they're getting kind of an award for it, like a mark for it, and it has some kind of consequence for them or whatever, they don't really make an effort to understand. Okay? And so we'll do a test I'll do what I can to encourage you to really understand it. And you know, we'll take it as we go. But look, I'm going to do whatever I can to encourage you. I can't prevent you from using a book. I can't prevent you from using your notes. But I would like you, okay, to remember why we're doing this. So please remember that the goal is that you get this. So that get your head around this, you kind of have to motivate yourself that way, okay? So anyway, guys, I hope you appreciated that. And yeah, we'll tell you more about the test as we get closer to it. Okay, signing off. Have a good night.